Hello geometry students, this is Ms. DeMoss and this is our first video lesson. Today we're going to be talking about volume of prisms and cylinders. Make sure during the course of this video that you write down everything that I write down. Pause the video whenever you need to if you need more time. First thing we need to define is volume, which is the space that a figure occupies. And we measure volume in cubic units like inches cubed, feet cubed, so on and so forth. So we're looking at how many cubes actually fit into a sheet. So we need some formulas. Here is the volume of a prism. I drew a trapezoidal prism, and the formula is area of the base times the height. Remember, B always stands for area of the base, and the bases are the congruent parallel faces. And that H stands for height, which is the height of the prism. Remember, that is the distance between the bases. So let's do an example using this formula. Let's find the volume of this rectangular prism. So draw this picture and label the dimensions. And remember, I always start with the formula, which is area of the base times height. So I need to decide what is the area of the base. Well, the area of the base is 24 times 20, and the height of the prism, the distance between the bases, is 10. And once I plug that in my calculator, I will get 4,800 centimeters cubed. Make sure you write centimeters cubed, not centimeters squared. That one was too easy though. Let's find the volume of a triangular prism. So let's draw this picture and label the dimensions. Again, I'm going to start with the formula, which is area of the base times the height. But what is the shape of the base? In this case, it's a triangle, and there is the base. I need to find the area of it. I know that the area of a triangle is 1/2 base times height, but the base and the height have to be perpendicular. So I'm going to draw in an altitude, a height, that's perpendicular to the base. And I need to find out the length of that orange segment. The original triangle was equiangular, so I know that the triangle here is actually a 30, 60, 90. If you didn't figure that out, you could have just used the Pythagorean theorem to find h. But I know that the height is the long side of this triangle, which is the short side times radical 3. So my height is 4 radical 3. I can now plug that in and find the area of my base. 1/2 times 8 times 4 radical 3, and I need to multiply that by the height of the prism, which is 10. Let's leave this in simplest radical form. I don't want to round, so let's do 1/2 times 8 times 4 times 10, and that will give you 160 square root of 3 inches cubed. Okay, let's now find the volume of cylinders. We need another formula, so let's draw a little picture and label some things. R stands for radius, H stands for height of the prism. The formula is exactly the same as for a cylinder, as for a prism. It's still area of the base times height, except in this case, the base is always a circle. So the area of the base will always be pi r squared times the height of the prism. I keep saying prism, of the cylinder. Okay, let's find the volume of a cylinder. Draw this picture, and we'll start by writing the formula, area of the base times height. If we want the area of the base, we need to know the radius, which they told you was 3 centimeters. So all we have to do is pi times 3 squared, multiply that by the height, and when we put this in terms of pi, we get 72 pi centimeters cubed. One last thing we have to talk about, composite figures. Let's write a definition. A composite figure is a 3D figure that is a combination of 2 or more simpler figures. And I'll show you an example of that on the next slide. We are going to find the volume of this thing, which is actually supposed to be a backpack. So take your time in drawing this thing. Hopefully you can draw it. And I want to find the volume of it. This is a composite figure because I put together 2 3-dimensional shapes. Hopefully you've noticed that we have a prism down there, and actually that's a half of a cylinder up on the top. So let's start by finding the volume of the half cylinder. The volume for a cylinder, the formula is area of the base times height, but I just have half of it. So I will do 1/2 times the area of the base times height. Area of the base means that I need to know what the radius is. What is the radius? Well, let's put it on the diagram. There's the radius. It's half of 12, which is 6. So I do 1/2 times pi times 6 squared. Remember, the 1/2 just comes from this being a half of a cylinder, and I multiply this by the height of the cylinder, which is 4 inches. Next thing we need to do is find the volume of the prism, which is area of the base times height. The area of the base would be 12 times 4, but I need to figure out what's the height of this prism. From top to bottom, we're told that the backpack is 17 inches. And up on the top here, we have that the radius of this cylinder is 6 inches. And so to find just this distance for the prism, we do 17 minus 6, which gives you 11. So we know that the volume of the prism will be 12 times 4 times the height, which is 11. When I do that calculation, I get 528. Now we need the volume of this whole thing, so I'm going to take those two calculations and put them together. 72 pi plus 528, plug that in my calculator. I'm going to round to the nearest whole number, and I get 754 inches cubed. That concludes lesson 10.5. Make sure you go back and watch it again if you missed anything, and I'll see you tomorrow.